Hello everybody, my name is Gang Tao. Today I'm going to introduce how we can leverage Timeplus and Ollama to build a RAG-based question answer system. So I'm the CTO and co-founder of Timeplus, and at Timeplus we try to build a best streaming processing system for you. So this is a report from Menlo Ventures about how a different architecture approach has been adopted compared to 2023 and this year, 2024. In this report, you can see that Retrieval-Augmented Generation, which is RAG, the adoption has been increased from 31% to 51%. So that's a big increase. And compared to that, you can see the pure just prompt engineering has been dropped significantly. And there's a 12% increase in leverage the agent, right? Something about, so the agent has been used quite a lot as well. So today I'm going to talk about RAG. So you can see that actually this year, the RAG has been the main architecture method to build LLM applications. So what is a RAG? According to this definition, actually, the RAG is just a method that can combine search for relevant information with generating response, right? So here's the process. You can see the RAG process. So basically, user asks some questions, and the system need construct a prompt sent to LLM. But as LLM is trained with some non-public data set, it has no knowledge of what's happening now or what's your private data, right? So and you have a lot of knowledge, your private knowledge, that need to be sending to LLM to answer these specific questions. But the LLM has a limitation that you cannot put everything in the context window because context window is limited. So what you are going to do is actually send the question. So the first you send all your knowledge in a vector database or whatever database, right? And you run a search, find the relevant information. That's the key part of the RAG, right? We just need send relevant information and construct the prompt. And then we send the prompt to LLM. At this time, your specific knowledge has been included in the prompt, so the LLM can answer the question with more accuracy, right? So I'm going to show you is I'm going to build a Timeplus knowledge question answer system. That means I have all the Timeplus knowledge documents, and what I'm going to do is actually similar to build a question answer system using Timeplus and Ollama. You can see Timeplus is used as the main interface. So when the user asks questions, it just sends a SQL because Timeplus is a SQL-based data processing engine. We send a SQL, and if we find a question, the Timeplus we can index all the Timeplus knowledge into Timeplus using Timeplus as just a vector database, right? And the embedding is actually here. We leverage Ollama to do the embedding. So we convert all the text knowledge as vectors and save in Timeplus. And then we can run we actually run a vector search using Timeplus and construct the relevant information into a prompt. And when the Timeplus in the SQL, we actually send the prompt to LLM. In this case, we run Ollama locally, running the Llama 3.2 1B model. So the local model will answer the question with the relevant information and return the response. And Timeplus will return the response back to the user. So that's the overall process of the Timeplus and Ollama based question answer system. Okay, So I'm going to show you how I build this system step by step. So the first thing to do is, as mentioned, we need to index all the knowledge and leverage using Timeplus as a vector store, a vector database. So what I'm going to do is I will create a stream in Timeplus. You can see it's the name is vector store, and it has name, ID. ID is just unique ID, generated unique ID. The text is the original text of the Timeplus doc, and the vector is the embedding in the vector format of the text. And then we can add more metadata. The metadata here is just a map, so we can search, not only search by vector, we actually can search or filter by the metadata, right? And talking about the embedding, we actually just run the Ollama, because Ollama is compatible with OpenAI. So here we actually just call the OpenAI client and talk to my local Ollama. And there's an embedding API we called, right? We call this this model called MXBAI embed large. This is one of the embedding model provided hosted by the Ollama. And then this is the API we use to turn the embedding, right? So I'm going to show you something about this one. So this is the Timeplus console UI. So you see we already create this vector store. So let me show create. So I run a script. All the code is open source here, but you can see we run a script that read all my local data, and we call the embedding method here to turn the text into embedding, and then we call the Timeplus SQL to insert all the data into vector store, right? We just run a local Python script that index all the data. So after index, actually, if you check, we can select from this vector store, and maybe we just return some of them. You can see actually the name is all Timeplus doc, so that means it's a collection of knowledge about Timeplus, right? And every single document I given an ID, and here's the original text, and here the vector is actually the embedding the vector format of this text. And there's some metadata. In this case, the metadata is just the original file name. For example, this one is from the function for JSON file. So, because Timeplus knowledge is just a lot of those documents. Okay, so that means I had all the knowledge indexed in this stream. Okay, so next one, I've already built this vector store. And then I want to, what's next is actually the search, right? How we search relevant information. For example, if a customer say, what is a stream query or some other questions, what a vector search do is actually we leverage a distance functions to search all the vectors I have and search the distance between the target vector and all the vector in my store, and we just sort all this distance, and in this case I found top 3, right? That's the shortest distance. That means the similarity of two vectors is actually just can be represented by the distance between two vectors, right? So in this case we run the L2 distance, and we order all the search result and find top 3, right? So that's something we call the just a vector search, right? So let's see. So I'm going to run this vector search. Say you can change whatever the question here. So we run this vector search. You can see it returns, when you're talking about what is streaming query, these three documents has a most relevant because it's a semantic search, right? It returns the relevant document to this question. But there's one thing I want to mention is this embedding functions, right? There's no embedding functions provided by the SQL engine of Timeplus. So this is actually remote functions. So when we call embedding, we actually call my local Ollama here. So turn this text into an embedding. So it's dedicate this job to a remote functions. So you can see here is what Timeplus remote function to do. So Timeplus we have, because SQL can do a lot of stuff, right? But some of those features or functions are hard to implement by just pure SQL function, right? So we leverage some Timeplus support different remote or customer functions, right? Fundamentally, we have JavaScript UDF, so user can actually write a JavaScript code to support the customer-defined SQL functions. And there's one UDF is Python-based, is under developing, because if you handle with data, right, the Python is the most popular ecosystem. There's a lot of data-related libraries and tools. This is under developing and will be there soon. And the other choice is a remote function. So the SQL user just define a web service or REST service, and the SQL will call the service and do the calculation and come back, right? So in this case, our embedding functions is actually just remote functions. So for example, if we call embedding, just say we give it a text, say hello world. So it's actually return vectors of the embedding of this text. It's hello world, right? So in this case, if we run the search, so the first thing is we turn the search target from text to a vector, and then we can run this vector search. Okay. So now I already have this vector search. So next step is actually I can construct a RAG-based prompt. So as mentioned, the RAG is just put the relevant information into your prompt, right? So in this case, we run this. You can see this with this SQL. We actually run the search. Here the subquery is just the vector search as I show. And the array string concat and with array reduce is actually because, like I mentioned, this query returns 3 results, 3 texts. We actually just merge these 3 texts into one text, and then we call the contact function. Say based on the following relevant information, we put the relevant docs, the merged the search result here, and we asked LLM to answer the questions. Right. So these are the prompts. Let's see if we run this prompt. So what we got is actually, you can see actually the prompt is just a lot of, we just merge all the text and we ask LLM to answer a question based on the top 3 relevant docs. You can change using different distance functions, or you can change the number of relevant functions, relevant docs you want to include, make it top 5, or in my case, I just use top 3. Okay, so and the last step is we just want to send this prompt to the LLM. So that we call the LLM and the LLM will generate a response based on this prompt. So in this case, you can see we just append this chart. We call this chart function, talking to the LLM. In my case, in this case, actually the chart function is also another UDF. So it's actually calling the I can show you the UDF function. So in our case, this is the backend service that's running to support the UDF of embedding and chart, right? So basically, embedding is just calling the OpenAI API, but under the hood, it's Ollama embedding model, and the chart is actually just send the prompt to the local Llama 3.2 1 billion model. It's a very small model, but it can do a lot of stuff. Okay, so let's see what this query do. So we just come back to this. We just add a chart. We just send this chart result. Before that, I want to show you the chart function. So in the SQL, you can just call the chart function, and this chart function actually send this message to LLM. So it's calling my local LLM. So hello world. No, it just return a hello world. Maybe I add something. How are you today? Okay, you can see the LLM return. Hello, I am just a language model. And you can ask complex questions, say why the sky is blue. And the LLM can answer some question about why the sky is blue. So it's actually just calling my backend Ollama model. So you can see there's a lot of information about why the sky is blue. So maybe I can show you my local Ollama. Yeah, this is all the models, and we can see what model is running. So you can see these are two the model I'm running. This is the embedding model, and this is the LLM I was using to answer the questions, right? Okay, so let's add this chart to the. I'm using this prompt as the chart. So this is the response, right? As response. So response, okay. So this is this response will be the LLM's questions about what is a streaming query based on the relevant information search from all the Timeplus stocks. Let's run this query. You can see with local model, it's not that fast. It takes some time, but it's already very good. You can see we sweep to scroll down to the final, and these are the questions answered by the LLM. So in case you want to ask different question, we just say, for example, what is a random stream? And in this case, the RAG pipeline actually will search the relevant information about random stream and construct the prompt and answer the questions. Let's see. Let's throw guys. So here's the explanation about what is a random stream. Okay. So that's overall process about how you can build such question answer system using Timeplus. So there's some summary, right? The key point of RAG is that just leverage vector search to get relevant information, right? It doesn't necessarily to be a vector search, right? Just the key is just getting relevant information. It could be vector search because it run a semantic search, right? And it can be other search. You can just run a SQL to run a query to filter out whatever the data you need and inject to the prompt as real-time content. And you can see we are using Ollama to support both the embedding and generate response. So Ollama is a good inference framework, so you can run local models easily, right? You don't have to depending on any other cloud providers. Of course, the local model didn't perform as good as the large models like ChatGPT 4.0, right? But it can do a lot of already, right? So, and with embedding UDF, you can see Timeplus leverages embedding run the vector search, right? So a lot of vector database doesn't support in embedding as part of the offering. So usually you need to have your own embedding. In our case, it's super easy. You can, if you want to use embedding, you can call OpenAI, or you can just leverage what I'm showing today, right? So a local Ollama-based embedding. And last, we integrate the chart UDF. So in your SQL, you can do everything. You don't have to deploy a lot of stuff. You just run from user point of view, right? Run such a question answer system is just running a search, a SQL search, right? So it can simplify your overall deployment of your large language model-based AI applications. Thank you. If you have any questions, please contact me, and thank you for watching my video.